Welcome back, folks, and today we're going to finally try and repair this defective stud with a Helicoil kit. So here's the kit, here's the inserts, and what I've done is previously drilled out the hole to match with the supply drill bit. Here's the fitting tools, which I'll show you later. Here's all the material that's come out. So what we can actually do is, I'll show you, I've matched up the depth so that it lines up with the other studs. For this kit, it's an M10 by 1.25 thread, and it comes with the supply tap. So what we're going to do is get a shifting spanner, put the tap in here, cut a new thread, and then we'll use the tool to insert the coil. Once the coil is in, we can then screw in the new stud. The other thing you want to do is well lubricate the tap so that this helps remove all the particles of the thread you're cutting as well. Do it gently, don't go against the resistance and try and force it. Just take your time, and if you encounter resistance, back it off, pull the tap out, clean the thread, re-lubricate, and put it back in. Hopefully you can see here one-handed. This is the tool that goes on, and it just gives you a proper leverage to then turn it inside. And what you want to do is make sure it's square and 90 degrees to the surface, because you don't want a wonky stud. You don't want it sitting at an angle or something once you're done. Try and get it as square as you can. It is difficult, and it's a very kind of time practice method. You just need a bit of experience with it, so be careful. And the most scary thing is measuring the depth you need to drill before you do this. So like I said, I used a steel rule. I went across, I put the stud in to the hole to see how much extra I needed to drill, and then I put a bit of tape around the end of the drill bit, and that let me drill in and stop at the tape to get the perfect height. Now that I've got the tapping started, I've got it in. It's pretty lined up as best I can. Pretty flush and parallel. Take this off, you can kind of see. So what I'm trying to make sure is it's pretty much true. I need to maybe tap this down a bit. It's just finding the angle, and once you start cutting the thread, it'll all, once you get a good turn on it, it'll all line up. It just goes in straight. So now what I do is, one-handed, put the shifter on, and basically we're just turning it, and as you can see, that's pretty free. There's no strong resistance, and you can start to see inside there, the thread cutter, there's bits of material coming out. So what I'll do is I'll do another couple of turns, then back it out completely, check to see that the thread's cut, re-lubricate it, and then go deeper. Okay, there you can see the new thread is cut on the inside. Thankfully this is an aluminium head, so there wasn't much resistance. It was pretty easy to do, which I'm surprised at, because normally these jobs go wrong, and that's not just me being cynical. You have to be exceptionally careful. You don't drill in, you could end up going through the water passage or whatever's on the inside of the bore there. You never know, it could be water, it could be drilling into the piston, who knows. So yeah, just be careful, take your time, measure again, over and over before you drill or cut anything. Next step is we're going to insert the helicoil in. So the helicoil sits in here, and this actually puts a stronger thread in. It's in between the new stud and the block. So here you can see one of the inserts, and we also have the special tool. Now I'm going to stop the camera here, get this set up, have a practice, and then I'll show you what it looks like after. Okay, quick flashback. So this is the tool. As you can see, there's a little gap, and that will actually, if you look down the center of the coil, there's a tang there, and that actually connects with the tool, and that lets you turn it and rotate it in. And what you have to do is, just off camera, I'd set this distance, so I put the tool into the hole and then push this down until it touched the block, so it's sitting flush. And then I tightened up the Allen key, so that gave me the correct height for the helicoil. And now, so I could get it started off camera and do the rest one-handed. So we put the tool in, that engages the tang at the bottom, and we just twist. And you push in with a bit of force, and that means that you're compressing the actual helicoil whilst the tang is holding on to it, and that lets you recess it in. Sorry, I had to cut the camera again, but there you can see helicoil's in. It's actually flush, so thankfully I managed to get my distances correct. And now the last bit is we use this punch to break the tang, which is the little vertical piece just in there. We break that off and that'll set the helicoil in, so that's it, a permanent fixture then. After that, we screw the stud in, bolt the exhaust manifold on and get the turbo fitted. Happy days, that's it over. Sorry, I had to cut the camera again, but there you can see helicoil's in. It's actually flush, so thankfully I managed to get my distances correct. And now the last bit is we use this punch to break the tang, which is the little vertical piece just in there. We break that off and that'll set the helicoil in, so that's it, a permanent fixture then. After that, we screw the stud in, bolt the exhaust manifold on and get the turbo fitted. Happy days, that's it over. Here's the final stage. I put 2 exhaust bolts on the stud, tightened them, and then I was able to turn the stud into the block. Now the clamps are on there so that I can actually turn the studs back, or the bolts back, sorry, without removing the stud. That let me remove them because they're pretty darn tight. Now, it's not completely perfect, but I think it's good enough that I'll get the manifold on, so we'll try that next for size. And there we go, test fitted. There's the new stud, all the other old ones on, and the manifold on in place with the turbo. So what I'll do now is check out the OEM gasket pack, find the correct exhaust manifold, put that on, put the exhaust manifold back on, and then tighten her all up to torque to spec. And that's it. Then I can finally start plumbing in the oil drains, the remaining brackets, things like that. Connect up this complete mess of vacuum hoses and water lines. And then after that, just take it from there and work on the manifold side. Okay, so here's what it looks like. I've given the exhaust runners, manifold, whatever you want to call it, and the ports I could clean up there. Still could use a bit of work, but they're pretty good, flush, wire brushed. And now we've got the lovely new Toyota gasket, which should go on roughly like this, I hope. Yeah. And this is just on for size now, obviously. Give you an idea of what it looks like. Somewhere here, I can't figure it out. I think it's quite difficult to do one-handed as well. There you go. That's what the new gasket is. It's like a bit like the head gasket. It's multi-layer steel. So it looks pretty good. Next thing is, before we put it on, we want to remove all the dirt, dust from the oil cooler and the turbo drain. And we've got the plug, the oil feed, the big bolt blanked. So I'm going to take a break now, just for this section of the video, because I've got some other things to do today. But I'll come back to it later, and the next job will be to actually finally bolt on the exhaust manifold and turbo, connect up the drain and the feed, and that's pretty much this side of the engine complete then. Then we'll move on to the timing gear, which I need to read up on just to be sure, and also then back onto the manifold side, and that will finally do it before we can hang the engine on the crane, bolt on the flywheel and clutch, and pretty much then get the gearbox on and it's ready to go in. So making progress. Other thing I've noticed is there's some cracks here, so I need to get some small vacuum hose, and also for here. So I mean, most of these I'll try and replace them as we go. And just off camera, I took the lid off the distributor. There's no ring there. 2 bolts, 8mm M8. Take the cap off, and I just wanted to make sure that the actual internal rotor was lining up with number 1 cylinder. So this fires number 1, which is over here, and the actual rotor that spins and hits the points inside the distributor, the 4 of them, it spins round, and it's actually lined up on number 1. The camshafts are all lined up inside here, previously done and torqued down, and that means that the piston is at the top dead center. Number 1 piston's up to the top of the block, so that means it's at the firing order for number 1. So when you crank it over, everything should be in sequence. As the rotor spins, it'll fire the correct what do you call it, the correct spark plug, and that'll give you the correct firing sequence. and then when it's running, you'll put a timing light on the pulley at the other end, and then you can slowly rotate, retard and adjust to get the timing where you need it to be, and then you'll tighten it down with these last couple of bolts, and that'll be the timing set. If you had aftermarket engine management, you could probably do a lot of it with you know, the map and things like that, but you need to get your base timing set from when the pulley's at 0, everything's lined up, and then you set your base timing. So that's basically it, but for now I think we're done. It's good progress. It went better than I thought, and I'm really glad that that infernal stud is repaired, because that would have been a new head job. And I do have a spare head over there, but I really didn't want to have to go and take all of this apart, buy a new set of head bolts, because these are torque to yield. You have to throw them out once you've tightened them if you remove them, and again set the valve lash and everything in the shims on a different head. It's worth noting, had the old MIG welder out, and probably have mentioned this, but I've gone through a load of nuts and bolts and things. Basically, when, if you can imagine, when the old stud had sheared off, I tried to weld these on so that I could twist them off, and I went through about 7 or 8 of them and got pretty damn good at welding again, bit of practice, but it was just really stuck in there. So normal methods are hit it with a hammer, try and use some nuts and bolts. If they don't let you twist it off, get a bigger vice clamp, which is over there, put it on it, try and twist it off. If that doesn't work, go to the welding route, weld it on. And in my case, it actually, there was so much torque, it sheared the stud even further. So that's the point where I kind of got desperate. I couldn't do any more welding. I was right down flush with the head, putting a bolt on, and I still couldn't turn it off. It just sheared in the head down to this point. So what you ended up doing was drilling out the old stud, and that's how we got to the helicoil route. That's kind of like your last chance saloon. And as I said, I started off in like a 3mm drill bit to get a nice hole, and then basically bored it out up to 8mm. And because I knew it was an M10, that meant there was 2mm remaining. So that meant when you got the drill bit with the helicoil kit, that just did the final kind of line bore, and then you were able to tap the thread and put the stud in with the helicoil. But yeah, I mean, helicoils are fantastic, and this is kind of one of the brilliant reasons they were invented. But you have to know what you're doing, and if you're not confident with drilling into a head and cutting a new thread, just don't even bother. Take it to a machine shop. They'll maybe charge you an hour or two's labour. It's not a big job for them, but they're professionals. They'll know what they're doing, and they'll do it better than I am, because I'm out of practice anyway. But it's good enough. It's in. It works. And yeah. So thanks for watching, everyone, and we'll continue again later. Just a final video tonight, just to show you that's all the exhaust manifold studs on. All nicely lubricated. The new stud from hell that's just been placed in there. Stuck the oil filter on to keep the block clean, and also the oil drain's on, and we've torqued up the oil supply bolt hidden under there. So everything under the manifold's nice and tight, everything's torqued up, the turbo's on, manifold's on, and it's looking good. And we've got this lovely new downpipe, everything's torqued up as well. A wee cheat for you, you can keep the oil filter off, get this bolt in first, and then you torque all of these up to 64 Newton meters. This is by BRD Development, and I got it from GT4 Play, and can't say a bad word against them. They're fantastic for delivery, so if you need any Celica parts, give them a shout. And I think they also do other JDM parts as well, so it's worth having a look. But yeah, so that's the hot side of the engine pretty much done. I've also spent a bit of time today bending these hoses into the correct shape, and also using some new good quality silicone vacuum line for the wastegate. And also on this side there's another wastegate to the turbo, the pressure side, also some new hoses and a new water outlet. So probably next job will be to get the sensor water tree on, connects into these two hoses, and also then the wee wiring, mini grip iron loom. And as I mentioned, I've already done the distributor to get number 1, the rotor lined up with number 1, and that's across to number 1 cylinder. So yeah, it's coming together, but it's a good time to quit, I think. So we'll call it a night for that, and hopefully it's starting to take shape.